morning, good afternoon, and good evening, everyone, and welcome to today's webinar hosted by NXP in partnership with Wind River. Today, we'll be talking about navigating the future and the importance of Zephyr in multi-OS environments. Today's speakers will include Brendan Slade, Director, MCU and MPU Horizontal Enablement at NXP, Graham Morphew, Senior Director at Product Marketing at Wind River. Then we also have Bill Girding, Software Architect at Wind River. And with that, I'll go ahead and hand it over to Graham from Wind River.
Thanks, Patricia. Today, we're going to be talking about the Zephyr project. And the Zephyr is a small footprint, open source, real-time operating system. We'll start off with an overview of the Zephyr project, its technology, some of the advantages, and some of the trends we're seeing around its adoption and use. Then we'll talk about why both NXP and Wind River are supporters of the Zephyr project and how we engage with the community and some of our joint customers that used Zephyr in their embedded systems projects. We'll then talk about some of the different ways we've seen customers deploy Zephyr with some specific focus on multi-OS use cases where Zephyr is being deployed in a more complex system alongside other operating systems. And we'll talk about how Wind River is helping our customers deploy some of these systems, as well as maintain their Zephyr-based solutions for their products, and describe one of the multi-OS projects that we've been recently involved in. So Bill and I, Bill will be talking later, are here representing Wind River, a company that's been a leader in the embedded software market for several decades now, with billions of deployed embedded devices. And Wind River is probably best known for our VxWorks RTOS, so you may be wondering why we're here today talking about Zephyr. Part of that answer involves talking a little bit about the history of Zephyr. Wind River was actually a key player in the creation of Zephyr. If you go back about 10 years or so, Wind River started a project to create a small RTOS or runtime executive that would run on low memory microcontrollers and on multi-core processors partitioned into virtualized systems, looking for a small little executive to run just above bare metal. And this project leveraged a code base that Wind River had acquired a few years before and upgraded it, creating this new RTOS. And I was actually the product manager at the time for this project. But to bring the history lesson to a quick conclusion, the code was then eventually released around 2016 as this open source Zephyr project. And the Zephyr community has continued to evolve that technology, and Wind River remains an active member of the Zephyr community. And we're here today as guests of NXP. Wind River and NXP have been partners for many, many years, going back to their Freescale and Motorola semiconductor days. And Wind River continues to be a platinum member of the NXP Partner Program. Wind River ensures that our software runs on a wide variety of NXP processors, including the S32, IMX, Layerscape families, as well as the legacy Core IQ PowerPC processors. We collaborate with NXP for our VxWorks RTOS, as I mentioned, and Zephyr now, which further expands the number of NXP products that Wind River supports. So currently, we're working with NXP on their NXP Tech Days that are running across North America and Europe, and some of those events are coming up, I think, in Boston and Detroit in the month of October. So if you live in those areas, come and talk to us there. So back to the subject of Zephyr, and let's get into a bit more information about Zephyr itself for anyone who may not be completely familiar with the Zephyr project. I already talked a little bit about the origin story of Zephyr and how it became an open source project. And this open source nature is certainly one of the key factors that has led to its adoption in the embedded marketplace and its popularity that we see today. And today it's really a true community, and the software is community developed. The Linux Foundation, which is hosting the project, has created a very active community that develops and evolves the technology. And the code base has really benefited from a number of upgrades since its Wind River days, in particular the kernel and the hardware abstraction layer. And getting into some more of those technical characteristics, Zephyr can be configured down to a very small footprint, under 10 kilobytes. And one of the configuration options is using sort of the core of a nano kernel versus a microkernel. And as low as it can be in those sort of single-digit kilobytes, it can also be scaled up with additional functionality that can be added with modular components. So this allows you to customize and optimize the Zephyr RTOS and its footprint for the needs of specific projects, and any sort of resource and timing constraints they may have. So this small size and responsiveness, those characteristics, make it ideal for microcontroller-based devices. It also has a very simple and well thought of hardware abstraction layer that makes it easy to port to new hardware platforms, and a tools ecosystem that includes IDEs, debuggers, and supporting libraries. And together, these attributes have helped Zephyr really rapidly expand its list of supported hardware and drive user adoption. And looking at that user adoption and that community growth, this graph shows that Zephyr has really certainly been gaining a lot of momentum and popularity in recent. And you can see it sort of compared against some of its contemporaries and similar solutions. Its community has really grown significantly, and has a diverse set of active contributors, which really shows how healthy that community is. And this hasn't gone unnoticed by some of the bigger semiconductor companies in the embedded marketplace, many of whom are actively enabling Zephyr across their products, especially on the microcontroller product lines. And NXP is one of those hardware providers that is a very active Zephyr member. And on that note, I'll turn it over to Brendan to now talk about how NXP is currently working with Zephyr.
Thank you, Graham. Yeah, I'm going to just spend a few minutes explaining what NXP is up to in the realm of Zephyr, for those of you that don't know. So it's, as you can see, if you go and look at NXP's website, or if you look at our various presentations, technical and to the markets and so on, you'll see that we're committed to help our customers staying ahead of the competition by enabling them to be ready to adapt and change. And of course, we want this change to be based on NXP's advanced products wherever possible, leveraging the great new technologies we're introducing. We really see a world where edge-connected devices are becoming increasingly aware through AI, so becoming smarter, and the need for power efficiency, improved safety, and reliable security are critical. So Zephyr is very well aligned with these goals and these market trends, and it's being developed from the ground up to function efficiently, safely, and securely, while providing the critical aspect of code portability. And this helps customers ensure that their investment, their IP, can be preserved and rapidly deployed on the latest processors and across a range of different products within their own portfolio. So NXP predicted a need for Zephyr back in 2016, and when we started to work with Wind River and the other founding partners on the project, and we've been very actively involved ever since. But with the global supply problems we all saw during the COVID epidemic, we have seen many customers really switch over to Zephyr and accelerate their investment and to better manage these challenges. And so we've also significantly increased our R&D investment and commitment to platform support since the end of last year. And along with our focus on committing to the Zephyr project and our device support, we obviously need to work on other areas of our ecosystem too. So that's why we're very happy to host Wind River today. They're one of our top partners, and the kind of services and capability they bring to the Zephyr enablement is critical for its success. So understanding a bit more about how we leverage existing IP with Zephyr and the way we approach it is what I'm going to talk about now. So our support model for enablement is and will continue to be based on upstreaming of support for our development platforms. So meaning that we want to follow the open source model, and in addition to that, though, we want to be able to provide early access to new products, and also there are some instances where, due to licensing restrictions, there are NXP hardware-specific things that can't be upstreamed, and those will be available through our downstream GitHub site. But our team is dedicated to actively supporting the upstream and not just some fork of NXP's flavor of Zephyr. So our MCU Zephyr enablement is based on production-grade, highly tested SDK drivers from our MCU Expresso suite of software and tools. And these are adapted to the Zephyr API, providing that hardware abstraction layer. So this provides consistency and efficiency, enables us to better support our customers across those using Zephyr and those who are not. So this slide is really about the MCU side, but we also leverage our Linux driver knowledge from the BSPs that we developed there and our Linux deployments to support Cortex-A cores, as you'll see in a moment. But these are more typically natively written drivers for Zephyr. So in addition to pre-existing MCU Expresso SDK testing in our board farms, we also leverage the great infrastructure that Zephyr brings for test. So we do a bunch of additional testing on top of that as well. As you can see, the kind of numbers of tests we were running over the most recent release 3.7. I won't go into all the details of this slide, but basically we've had Zephyr support for our general purpose MCUs for some time. We already had IMX RT crossover processors, LPC 5500, and other slightly older products supported with Zephyr, and we've expanded our device support significantly already this year. So our MCX MCUs already quite well supported, with more drivers being added on top of baseline support all the time. We also contribute very actively in several areas of the technology that's shared across the Zephyr project, like Wi-Fi, SDIO, audio frameworks, USB, and other areas. So I do want to point out here that, you know, even if you're not a member of the Zephyr project, you can contribute to the Zephyr project. You can and do pull requests, and you can make contributions, and the community looks at that code, checks for quality, and then can accept a pull request. So it's one of the great things about it is there's so many companies involved, and there's a shared responsibility to maintain quality. So that's, as I said, a big benefit. And some of our devices have actually been originating from device support that's written by other companies. So that's worked out well on a mutual basis. So on the last slide I'm going to present today, if you can move on to that one, Graham, is just to mention around the Cortex-A device support on our IMX family. So we have support for our Cortex-A devices in applications where we see customers using some of the Cortex-A's cores in our IMX devices for real-time applications where they need very high performance. So those tend to be simpler control applications, but where timing performance is very important, things like robotics, industrial automation, and so on. So that's really driven our Cortex-A support, but we are increasing the support to other peripherals as well. So that was a very quick look about what we're doing, our level of investment and commitment to Zephyr. I'm going to hand you over to Bill now, who's going to dig into some more interesting technical details of some of the other application use cases.
Hi, thanks, Brendan. Just going to go over some example uses of Zephyr here. Starting on the left, consider this kind of the bread and butter use of Zephyr, where you have a microcontroller. It's small, it's maybe battery powered. Zephyr fits, of course, into the internal flash and internal SRAM of these microcontrollers. And I'm showing here an example MCX microcontroller from NXP. So this might be a data logger. It could be, a data logger such as a Fitbit, where I'm not showing Bluetooth here, but it would have some, data acquisition, inertial or pressure or something, and then communicate with your iPhone or Android device over Bluetooth. Or it could be maybe a cycling computer where it's communicating with the sensors over a Zigbee radio or something like that, and then in turn communicates with your iPhone, Android over Bluetooth. So that's the Zephyr. The point of this presentation, of course, is about multi-OS. So going to the right in the middle there, we have a multi-OS example where you have a NXP SoC, perhaps the IMX8QM, running VxWorks, or perhaps Linux on the Cortex A53 cores, and then Zephyr on the Cortex M4 cores. You might do this just to get that hard real-time performance for certain IOs that you would allocate to the Cortex M4 and Zephyr. Another example of this that we're seeing is that customers, in dealing with hardware obsolescence, maybe for like Intel 8051 microcontrollers, they're coalescing an external system and the 8051 portion into an NXP SoC, and in doing so, getting that coalescence and maybe also giving them a path to enhancing their system is part of dealing with the obsolescence of the older microcontrollers. And on the right, we see a more loosely coupled situation where you have Linux running on an SoC and communicating perhaps over CAN bus to a constellation of Zephyr-based microcontrollers. Certainly with that, you could have all kinds of communication options over the CAN bus, J1939, DeviceNet, CAN open, and so forth. So those are three examples. The last two, of course, are the multi-OS examples. So, I mean, Zephyr advantages, Graham is kind of, and Brendan have kind of touched on this already, but, it's small. In my own personal experience on some certain microcontrollers, just a hello world or a Blinky example, the bin file was 15K in size. I'm sure you could push that down if need be. It's open source, and as Graham pointed out, it's a very active community. Lots of contributions and activity there on the GitHub. It's a growing ecosystem. New microcontrollers and new reference boards are coming online month by month. And the supported list of hardware. I just did a quick count on the Zephyr website of the supported reference boards, and looks to be 600 plus supported reference boards that are out there for you to choose from. And combining it with other complex OSs, certainly there's lots of protocols that Zephyr brings to the table for you to accomplish that. So if you're considering using Zephyr, you might want to ask yourself these questions. Do you have the skills in-house and the team with the knowledge and experience to do this? The real-time skills, experience with Zephyr or experience with microcontrollers is something to consider. If the firmware that you're going to have running on Zephyr needs to be protected in any way, do you have experience in protecting that firmware or protecting the system? And also, in thinking about the life cycle of your product, do you have the plan to maintain staff through that life cycle to maintain the product? And also, experience with working with the Zephyr open source community is also something to consider. Wind River as a services organization, and what we can do for you is, extend your experience here, initially help you arrive at an optimal architecture for your Zephyr-based system or multi-OS system, considering NRE and lifecycle costs and getting you to an optimal design. And then when you have your design in place, maybe you want to augment your staff to perhaps have Wind River develop your platform, which we typically refer to as a BSP, board support package. And we could also, provide services to maintain your platform over a long term. And then also is our experience with the open source community is advocating for you. If there's some IP or some feature that's been new and developed for your platform, we could advocate to get that carried forward and get that pushed upstream and become part of Zephyr long term. So Graham alluded to a project that we've done, and this is this project, and this is a medical device that monitors and it does provide precise environmental control of tissue cultures. The system consists of a constellation of data acquisition control nodes that are implemented with a microcontroller and Zephyr, and then an operator interface and a gateway to the cloud that's implemented with the NXP SoC running Linux. This particular customer had no experience with Zephyr, really no experience with real-time OSs, and no experience with getting a medical device, certified adequately for the FDA. So Wind River developed a platform for them, did the board support packages and the outfitting. We also developed IP for communicating between the Linux node and the microcontroller nodes over CAN. This particular customer really wanted to use IP, so we used IP over, developed an IP over CAN implementation, and then on top of that, the customer used MQTT to publish data to the cloud. So here's an example of how we, augmented the customer's team and got them to market quickly. They also made use of some other Wind River products to implement over-the-air updates to their system and also provide a digital feedback loop capability. And that's back to you, Graham.
Yeah, thanks, Bill. So looking into the future of Zephyr with its current momentum, it seems likely that Zephyr is going to continue down its path of growing its community and the ecosystem. So that's why all of these different companies are engaged. They're all sort of, this will continue. And there's also sort of this, looking at the market, an opportunity that's been created for Zephyr to fill maybe some holes that are being left by the end of life of some of the alternatives, right? So, ARM's embed, for example, is on a path to end of life, and Siemens has announced the end coming for Nucleus RTOS, which has been around for a long time. And there's other examples. So this gap is in some ways being filled by Zephyr and this open source approach. And it seems that in some ways, Zephyr is on this path, almost have this goal that it's becoming like the Linux of microcontrollers, with this vibrant community and significant adoption. But when you're talking about the future, like Linux, with this kind of community development approach, the predictability of the roadmap technologies is a little bit uncertain, and that's not a bad thing. It's just hard to predict. And there are some investments that certainly the community is clearly behind. One of those is around safety certification, where there's a community project group that's trying to make it easier for Zephyr to be used in safety certified products, and they're specifically focusing on the IEC 61508 standard for functional safety certification, which applies to industrial devices. And if they're successful there, some of those activities could certainly apply to other functional safety standards. But these types of things is usually a long-term project, and Wind River has a lot of experience with these. With the background that we have in safety certification across multiple industries, it's always a time-consuming endeavor. And with a community environment, it can be tricky to organize and allocate work across the developers in that community, and that's usually the challenge sort of these open source projects run into as they get into safety certification. And so, certainly that's where we have customers coming to us asking for help to potentially fill that gap in the meantime. Security is also another key area where we see a lot of community investment and requirements and concern from Zephyr members in terms of future investment. And Zephyr is always adopting new communication and networking stacks to widen the scope of the type of applications that Zephyr can support. And as you've heard of today, our particular focus and what we're talking about today is really this scope outside the single microcontroller use case, where we think Zephyr offers a great option in these multi-OS systems, especially ones that present this big little architecture where you have these larger application cores, usually ARM Cortex-A cores, and also beside them one or more smaller M cores from ARM that are doing some kind of specialized function typically, which might be special type of I/O that requires low latency and high responsiveness. It might be a security coprocessor, or in some cases a functional safety island, right? So, and there's many other scenarios where these architectures are appearing, and we think they're ideal for this architecture where Zephyr is potentially running on those smaller cores alongside a larger OS, be it a larger real-time operating system, or Linux, or Android, or maybe even Windows or Mac OS. But and we see like the use of these types of heterogeneous multi-core processors growing and continue to grow, and we see them on the roadmaps of our semiconductor partners, and we're predicting that the use case of Zephyr will expand with it in that particular scenario. So to recap a little bit of what we've talked about today, Wind River and NXP have this long history of working together and collaborating on software for embedded systems. And a significant area of collaboration has always been around open source and specifically open source operating systems. Mostly that's been around Linux, of course, as being the most famous open source operating system, specifically in the embedded space, the Yocto project. But now with NXP and Wind River, both members of the Zephyr project and that community growing very rapidly over the last few years, there's more collaboration that's happening around Zephyr, with NXP supporting Zephyr on many of their microcontrollers and microprocessors, and Wind River providing support and services for companies using Zephyr in their embedded designs, and maybe taking a lot of these companies that may have had very basic microcontrollers and simple sort of bare metal software that runs on it. They're kind of upscaling the complexity of their software as their customers are demanding more and more functionality of those products, and they're looking for help to kind of make that leap to a real-time operating system on some of these microcontrollers, and also looking at how they can solve those problems of the heterogeneous big little architectures, which we think is particularly of interest for Wind River. And so these complex systems, multi-core SoCs that include these big little architectures, ultimately we see the use of those expanding, and we think Zephyr offers a great solution side by side with a larger sort of application level operating system to solve the kinds of problems, things like the consolidation of systems, designs that we see a lot of our customers engaging in. So with that, thank you for attending our talk today, this webinar. Hopefully you found some information and the points of views that we shared to be interesting and useful. certainly feel free to reach out to us either on the Wind River side or the NXP side if you're looking for more information about Zephyr or some of the use cases that we talked about. And with that, I think I'll turn it back to Brendan, who's going to be hosting our Q&A session.
Yeah, thank you, Graham. Yeah, we've got quite a lot of questions coming in. So we'll see how many we can get to. There's a few around comparisons with FreeRTOS, so I'm going to say a few things on that, and maybe Bill might want to follow up on some of the others. So there's a question saying, what are the advantages of Zephyr over FreeRTOS? I think FreeRTOS is a great RTOS. It's really nice, straightforward to use. It's very prevalent in the industry. And it's very good if you're making a first step in from bare metal into a situation where you need an RTOS. And there's another question about that as well, about when to use Zephyr versus bare metal. But really where Zephyr starts to come into its own is where you're looking for all the other middleware that comes along with it and a lot of the kernel features. So it has many features to do with when you want to monitor things and so on that the FreeRTOS doesn't come with. And it also has hardware abstraction as well. So that's one of the big advantages with Zephyr, is a standard hardware abstraction. So there's a couple of things come to mind. Performance-wise, it's kind of swings and roundabouts. They're very similar performance-wise. Is there anything else, Bill, you want to add to that in comparison with FreeRTOS?
I mean, it's open source and there's an open community. And I would just say just the support of all the microcontrollers that are out there and the packages that are available with Zephyr, I find to be quite impressive.
Well, maybe this one steps over nicely to a different related topic. This is where people want to decide whether they should use VxWorks or they should use Zephyr. Any thoughts on that, Bill?
I mean, capabilities, footprint. I think the footprint would be the primary consideration of making that choice. Certainly, Zephyr is in the microcontroller space. So, I mean, if you want to use a microcontroller, I think you would, tend to lean towards Zephyr. If you're doing something with an SoC and you need more robust networking and more robust security, and if you're running on Cortex 8 cores, you might consider VxWorks, or even higher than that, consider Linux. But primarily, I think it's the footprint and the microcontroller that you're targeting is going to be your primary consideration.
Yeah, VxWorks has the long history in safety critical applications, right, Bill? So you've in avionics and other areas like this. So the robustness level is very high.
Yeah, just to chime in, yeah, I mean, it does come down to, like, when we're talking about safety certification, as I mentioned, there's sort of this project to certify or get certification documentation and evidence for Zephyr. But if you look at VxWorks, we have it out of the box, right? And it's ready to go, as opposed to sort of relying on a community. And at the end of the day, VxWorks is just sort of more feature-rich, support for things like containers, as Bill said, the networking factor. But along with that extra functionality comes extra size, right? So yeah, it really comes down to, and why Wind River created, the original project that I alluded to was just to, get into those sort of sub 20K, sub 50K type of spaces in a microcontroller, where maybe you just have a dedicated fixed amount of RAM or flash to run into, and you don't necessarily need all the functionality of a VxWorks, and maybe you're scaling up from, as I said before, like a bare metal scenario to, okay, now my software is a bit more complex. I want some multitasking. I want some more sort of a base layer platform to run on top of, and Zephyr is a good step up from kind of running completely like bare metal, or something even more primitive, if you're coming from a 16 or very low end 32-bit microcontroller, and taking that next step up in terms of the complexity of the system that you're building.
Yeah, and to add to that point on the safety certification, I guess the Zephyr project, that is one of the key things. So there is efforts on IEC 61508 right now, and there's other companies who are very interested in that area. Some of the partners you will see in there, like Cariad, just joined on the automotive side, and we also have companies from the medical side as well that are pushing for those things. So they will come. VxWorks is somewhere ahead right now. It is an objective of Zephyr to achieve some of those certification goals as well, but it depends that those are focused on the kernel certifications first. So moving on to some other questions. So there's quite a few questions around support of NXP platforms. So you can go to the Zephyr project and zephyrproject.org and look at supported platforms. You will see that there's questions around IMX9. Yes, we do have support there. We will be adding support for the newer IMX9 devices, 8mm as well. We have that too. That's also there, so please go take a look at that. Support for the SE050 secure element, yes, there is support for that too on some platforms, and you'll see NXP adding more and more support from various different groups like our analog devices and support for those kind of analog interfaces and so on coming too. There's a few questions that are fairly detailed around sleep modes and boot times and stuff. I think it's best to get in contact. We'll make a note of your names there and get set up some follow-up on those. There's also questions around the Twister environment, which is the test environment from Man Singh. Yeah, I'd encourage you, Man, to post on the Zephyr community. They're very, very supportive. With questions, so I'd encourage you to try and get some help there. Please do reach out. If it's on an NXP platform, you can reach out to our community. We can try and help you. There's a lot of questions. Questions about NXP's real-time edge software working with Zephyr. Yes, it does, and that's already included in the distribution. What's the open source license that Zephyr is provided under?
Yeah, so it's an Apache 2 license, I believe, and if you're not an expert on open source licensing, and I don't claim to be, basically what that means is it's a lot more flexible in terms of kind of creating derivative software, modifying it, and you can sort of relicense parts of essentially relicense parts of the additions that you make or the modifications, and you're not encumbered with sort of that copyleft style of GPL, right? So that's a big sort of contrast in terms of, we've kind of compared Zephyr to Linux in some way. Linux is, got all of the GPL fund licensing obligations that you have, and the Apache licensing is much more flexible in that you can kind of create derivatives and go on with it. Now, of course, if you want to contribute to Zephyr, then I'm sure one of the requirements is that what you're contributing, goes into that project and is part of that Apache licensing. So it's very, bottom line, it's a pretty flexible open source license. So, and I think that was a must-have for something like a Zephyr, right? It wouldn't have been as successful with like a GPL style license.
Yeah, we also have quite a few questions, Graham, around combining Linux with Zephyr. And I know we have VxWorks and Zephyr. Is there anything on the WindRiver side around Linux and Zephyr, or are you focused primarily on the VxWorks and Zephyr solutions?
Yeah, well, I mean, certainly, and the example that Bill used, in that third option, maybe I can flip back to it so I can talk to it a bit more. The third scenario, as you can see here, is Linux alongside of Zephyr, and that can be done in many ways. But I mean, really, I think the one that's most obvious to us is as I was talking about that big little architecture that's become popular with larger application cores, and they can run Linux, they can run Android, they can run VxWorks. Those are sort of the three scenarios we see the most in terms of talking to our customers while Zephyr is running on some of these specialized cores. And that's, what those cores do really comes down to, in some cases, what the semiconductor manufacturer has put together in terms of a product, but also what types of applications the customers are building. But they tend to have these kind of almost dedicated functionality scenarios versus the more general purpose, larger the Cortex A cores on the ARM side. So I hope that answered your question when but yeah, I think the most common scenario we see, it's probably even because of, we have a lot of our VxWorks customers coming to us, right, who are longtime VxWorks users, and they're adopting some of these new chips and wanting something to run on those M-class cores, and they want kind of a combined solution from a support perspective from a single vendor, and so that they are a good fit to talk to us on the services side and kind of put together a solution for them. And on the Linux side, we see much the same thing, but there we probably have more sort of what we would call greenfield customers coming to us, and may have been using other, different types of Linux, right? So, obviously we have on the Wind River side, we have Wind River Linux. We also have just announced this Elixir, which is a Debian-based solution. But any Linux could potentially run on those A cores, or Android, which is sort of a Linux-based system. Yeah, so there's lots of different scenarios that we can support for sure.
Yeah, I think the question, because you had this in the slide, I didn't ask my question terribly well, but there's quite a few people asking about this combination of OSs on chip as well as in the kind of scenario you have here. So that, just to clarify, that's something that Wind River could also engage with customers on, right?
Yeah, I mean, if the question is, do we support scenarios that are both where everything's on one, SoC in terms of cores, or potentially in the case here where there's a bus and maybe they're separate chips on the same board instead. I mean, for us, they're very similar scenarios. It's just how the communication channels might change between these cores, how resources get shared, things like that. But fundamentally, conceptually, they're very similar.
Yeah. Okay. Thank you, Graham. I think we covered that one. There's a couple of questions related to long-term support. So Zephyr has a 2-year LTS cycle. Is there anything you want to add to that in terms of what Wind River can do to help customers with long-term support, Graham?
Yeah, I mean, this is something that we do all the time for our customers on the Linux side of the business, because it's a very common problem. Like open source communities are great in supporting the most recent sort of bleeding edge versions of that open source project. But if you've sort of released a product and you've got a kernel or a version of Zephyr RTOS that's now a few years old, the community is typically not that interested in backporting bug fixes and security updates and things like that. So that's something we do a lot of for our customers on the Linux side, and it's definitely something that we can do and are doing for Zephyr customers. And we assume that's part of the sort of the package that we offer with customers who have long product cycles, right? So automotive, you put your car out into the market, and that's 10 to 20 years. Aerospace and defense, similar, if not longer, product life cycles. And once you're sort of, swapping out an entire version of an operating system in a running deployed system is still a risky prospect. So there's a lot of sort of locked in solutions on specific versions, whether it's Linux or Zephyr, and having a company that is backing you up and supporting you in terms of that maintenance is something that we definitely do quite a bit of.
Okay, thank you, Graham. There's quite a few questions around build environments and people understanding. There is a transition for those from the MCU world coming across to using Zephyr, because it uses quite powerful tools like West, which can reach across different repos and build things. So that could be something unfamiliar. Again, I'd encourage people to look at to contact the community with questions. There's also training available from Doulos, AC6, both have training. We have some training on the NXP side to help people understand. There's good training from Nordic as well, one of the other main contributors to the Zephyr project from the semiconductor side. And we do hope to provide more training over time, but there's quite a lot of resources out there. There's a lot of resources on YouTube to help people understand. So I would encourage you, it may seem a bit daunting at first. You've got to come from the MCU bare metal or basic RTOS world into understanding things like device trees, K-config and so on. But once you're over that curve, we pretty universally hear people really see the power and benefits of working with that kind of build system. A question around symmetric multi-processor support. That is something that comes with the Zephyr kernel. We don't have, in the NXP side, our devices tend to be a bit of a more asymmetric architecture on the microcontroller side, so we don't have examples out there yet, but that is something that comes from the very origins of the Zephyr RTOS, which started with something called Virtuoso, which is a pioneer in multiprocessing. Can you address the build system requirements and how to obtain kernel-aware debug plugins or shared objects for Linux debugging of the kernel? Bit of a deep question there, Bill.
So from Linux, I interpret this as from Linux debug.
The Linux side, it's Linux, not Zephyr. So,
well, there's the KGDB and the GDB. I really wasn't thinking of Linux aspects, and this is more a Zephyr-oriented presentation. Is there any more color you can add to that, Brendan?
not really. I think if someone looking for help on how to get the kernel-aware debug and objects helping debugging a Linux kernel, it's a little bit off topic, so maybe we can follow that. So around Cortex R cores, so can we run Zephyr on ARM Cortex R MCUs? Well, yeah, MCUs where some critical apps are designed. I think we're talking about safety critical applications on Cortex R cores with Zephyr. I think Graham kind of touched on this with the certification side, but do you guys have any comments around safety critical applications with Zephyr on Cortex R cores?
Yeah, I mean, certainly our cores, you know, if you look at it from a pure kind of RTOS perspective, the difference between A core, R core, and M core come down to you know specific functionality of those cores. But and something like Zephyr can run something that's very, very stripped down, right? Like no MPU, no MMU. So certainly Zephyr can run on our cores. I don't know, Brendan, when I'm done, if you can comment if there's NXP solutions with our cores in them that might be targeted for Zephyr. But certainly that is probably where we'll see more of the use cases of Zephyr in a safety certified environment, right? So certainly if there's a project today, we could leverage what the community has done on the safety certified side so far and continue that along, right? I mean, it's given the sort of code base of Zephyr, how you put it together, essentially what you're doing is if you have a simple application, then you can run it on a scaled down simple footprint of Zephyr. And then that footprint ultimately determines how much work you're going to do to have to safety certify it. So certainly that's something you could do today, right? It's just what's going to happen as they safety certify more of the Zephyr code base is that it's going to save you time and essentially money in terms of getting that fully safety certified for a specific functional safety standard. So yeah, I think hardcores are going to be part of that, and hardcores are typically targeted towards functional safety types of use cases, from what I've seen.
Yeah, on the NXP side, I come from the industrial IoT business side of things, so non-automotive primarily, and so our product portfolio doesn't include Cortex R-Cores devices. Our automotive team does have that, and obviously they're focused on that. We're seeing some interest on the automotive side for Zephyr. It's early days, but as I mentioned, Cariad is a big new platinum member for Zephyr, so we can see the interest is there. So there is some support on some of our devices, S32 devices out there, but it's more preliminary. But we expect the interest to increase in Zephyr on those kind of devices. So no hard plans right now, but would expect to keep it to evolve and grow. Right. So there's a question here about, so Zephyr has a lot of contributions. Does that mean it's constantly in flux and changing? And would that be a big issue in the future? I would say, I'll give my comments here. Maybe then Graham or Bill, you can chime in. So because the Zephyr committee is that there's a lot of teams very involved in this, they do strive to avoid compatibility breaks, and there was one in the last release because they realized they had to make a change in the way that boards were described in the system. So that was a breaking change. Typically API changes are a no-no, so that's avoided, but those things could happen. But I would say you've also got a couple different routes here. You can work with the tag. It's all open source, so you can fork from that and have your own downstream version of what you're doing. You can also work with Wind River, I believe, that could help you with some of these longer term support issues that Graham mentioned. But Graham, maybe you can add to that or comment further.
Yeah, I mean, and this is a challenge that any operating system faces, right? Is the combined, the sort of the idea that, hey, we want to innovate the technology, and that involves making changes. But if you're sort of locked into a specific version of an operating system and you don't want those changes, then you're sort of left on an island, right? And the comparison I make is sort of, like my aging mother has an iPhone that's old and she can't get iOS updates for it anymore, but she doesn't want a new phone because that would be confusing, right? So we do, as I talked about earlier, is we support and extend the life and support maintenance for those older versions of products. And this isn't strictly an open source issue either. We have a lot of customers who use older versions of VxWorks as well. And in particular, that gets more common when you're talking about safety certification, right? So if you imagine you're on one version of an operating system and now there's a new version and maybe you'd like to switch to it, but that's going to kickstart or invalidate your entire certification process thus far, you may be highly hesitant to make that upgrade unless there's a really compelling business reason to do it. So open source communities do have like that desirable fervor around innovation and making changes. How they're governed sort of affects how disruptive some of those changes may be, and preserving APIs is usually at the top of the list. Because if you the more you break, the more the less likely you are to have people continue to use it, right? If there's these big sort of discontinuities. So and I believe Zephyr has some versions that they designated as longer term support within the community as well. So it's those LTS versions that will be targeted for sort of these safety certification projects, because they just have to have longer life cycles. So the answer to the question, there's always this chance with any operating system that in order to achieve a specific goal, there's going to be some significant changes to the kernel and you may have to choose that. Okay, I'm not going to make the leap now. I'm going to stick with the previous version for this life cycle of this product, and then upgrade later. That comes with the territory, I think, with any software.
Okay, thank you, Graham. We've also got a few questions around development environments. So a lot of the Zephyr development is really kind of command line oriented building, originating from Linux, I guess. But there are more and more tools appearing, more support appearing all the time. On the NXP side, we're focusing our development around Visual Studio Code, our extension, our M6 extension for that, and trying to make things more comfortable for people who are more familiar with an IDE. Nice thing about Visual Studio Code is you can actually mix extensions from us and Nordic and others, so you can kind of play around in the different worlds. And there's various different extensions to help things like looking at device trees. So I would encourage you to look at those options, look at what we have, look at what Nordic has, and some of the others as well. That might make you feel a bit more comfortable. As I said, we touched on with West, getting comfortable with West and CMake and so on, part of the learning process with Zephyr. Is there anything you'd want to comment on that, Bill, from the development side, recommendations from the Wind River side, what you guys use and recommend?
Well, so far our experience is just using the command line, using the West and the CMake and so forth. So no experience from my part as far as integrating with Visual Studio Code, but that seems encouraging.
Okay, and on that same front, I think there was the question about the Linux kernel where debugging was actually about debugging on a Linux platform. I think it's some more follow-up questions from Dwayne. I'm not able to read all those right now, but yeah, the VS Code also runs on Linux platforms too, so that's a benefit there. I know even like IAR is working on Zephyr as well, and they're doing more things in this area too. They have VS Code capabilities too. So there are solutions out there on iOS, Linux, and Windows for people who want to choose across those different platforms. So I think we're right about at the end here now, right, Patricia? So
Yeah, so thank you guys for going through that presentation for us today. But yeah, thank you for joining today, and I hope everyone has a great rest of your day.